everybody, today we're going to be going over factoring and expanding algebraic expressions. And we actually kind of did a little bit of this earlier in the year. So some of this should actually be a review of the distributive property and the reverse of the distributive property. So I'm actually going to go through the guided practice through the odds on page 240, and you're going to do the evens on 240. So let's take a look at the odds, and then I'll do those with you together, and then you can do the evens on your own. So let's look at number one. Number one, I have 3 times x plus 4, okay? So if you remember the distributive property, we take the number in front of the parentheses and we distribute it using multiplication to each of the numbers inside the parentheses. So I'm going to put 3 times x plus 3 times 4. So I'm distributing the 3 to multiplying it by the x, and then 3 multiplying it by the 4. Then I just simplify as much as I can. This is left as 3x, and 3 times 4 is 12, so this is in its simplest form. Let's take a look at number 3. Number 3 says 2 times 7 plus 6x. So I'm going to take the 2 and distribute it to the 7 to get 2 times 7. And then I'm going to take the 2 again and distribute it to the 6x. And I'm going to get 2 times 6x. I'm left with 2 times 7 is 14. And 2 times 6x. So that's saying I have 6x plus 6x is going to be 12x's. That's my simplest form, and I'm going to leave it just like that. Let's go over number 5. Number 5 says 4 times 4y minus 1. So the difference between this one and the previous problem is instead of a plus 1, we have a subtract 1. So I'm still going to take that 4, and I'm going to distribute it to the 4y. So I get 4 times 4y minus the 4 times the 1. Okay? I'm left with 4 times 4 is 16y minus 4. That's my simplest form. Let me go over number 7 with you. I have 6 times x plus 5. And I want to know if this is going to be equal to 6x plus 30. Well, let's try to make this as simple as I can. 6 times x, it's going to be 6 times x, plus 6 times 5. I'm just bringing this down because I did not touch anything on the right side of my equation. 6x plus 6 times 5, which is 30, and they are equal, so this problem is equivalent. All right, and let's look at the final answer of number 9. Number 9 says 4 times y minus 4. Is that going to be equal to 4y minus 4? So I'm going to distribute the 4 to the 4y minus 4 times 4. And I want to know if that's going to be equal to 4y minus 4. So I have 4y minus 4 times 4 is 16. That is not going to be equal to 4y minus 4. So this one is not equivalent. Right now I'd like you to pause the video and I'd like you to try out the evens 2, 4, 6, 8, 10 on page 240 and work with the distributive property of expanding the expression. So go ahead and pause the video now, and then I'll post the answers when the class is done. Okay, here are the answers to 2, 4, 6, 8, and 10. Number 2 is 2x plus 18. Number 4 is 5y minus 15. 6 is going to be 45x minus 18. 8 is going to be equivalent, and 10 is going to be not equivalent. So that's how we expand our expression when we have a number outside of a parentheses. We're really multiplying that by everything inside the parentheses. Okay? The next thing we're going to be doing is factoring. And if you remember, when we factored out earlier in the year, we used the greatest common factor to put on the outside. So let me show you some examples of that. I'm going to go through the odds on page 243, and then I'd like you to try the evens on my own in your notebook. So number 11, I see that I have 3x plus 3, okay? And I want to look for a number, preferably the greatest common factor, that can go into both 3x and 3. So if I were to make a factor tree on the side here, I would see that I have 3x is really 3 times x, and 3 is a prime number, so it's going to be 3 times 1 times x. If I were to make a factor tree of 3 and 1, 3, it'd be 3 times 1. Again, I have to find all the partners. 1 doesn't matter, but I have partners of 3. So I'm going to pull 3 on the outside of my parentheses, so because that's my GCF. Now, many students would be able to see that 3 can go into both 3x and 3, but when all else fails, you can always make a factor tree. So I want to know 3x times what? 3 times what is going to be 3x? 3 times x is going to be 3x. And 3 times what is going to be 3? Well, 3 times positive 1. So this would be my factored expression of 3x plus 3, would be 3x plus 1. So don't worry. The more we do this, the more you're going to get a hang of it, the more you'll remember greatest common factor. So let's look at number 13. In number 13, I have 8 plus 6y. So I'm going to break both of these numbers down using a factor tree. I know 8 is 4 times 2, which can be broken down into a product of primes of 2 times 2 times 2. 6y can be broken down to 6 times y, which can be broken down to a product of primes of 3 times 2 times y. So now I'm going to circle the partners. I see that they have 2 and 2 in common. Therefore, my GCF of 8 and 6y is going to be 2. That is going to be the number that I am going to bring to the outside of my parentheses. So now I have to ask myself, 2 times what is 8? I know 2 times 4 is 8, plus 2 times what is 6y? Well, I know 2 times 3 is 6, and I'm left with a y. So it's going to be 2 times 4 plus 3y. One way you can check to make sure that you have the right factoring is by doing the expanded. 2 times 4 is 8, and 2 times 3y is 6y. So if you get back to where you began, then you know you're on the right track. Let's take a look at number 15. Number 15 has 4 minus 10z. For right now, I'm just going to pretend that the negative sign or that subtraction sign is not there. And I'm going to look at it as 4 and 10z. Those are what I'm going to make my factor trees on. Well, I know 4 is 2 times 2. And I know 10z is going to be 10 times z. And then 5 times 2 times z. I'm going to look at what they have in common. I see that they have 2 in common, and that is the only number they have in common. So my GCF is going to be 2. That is the number I'm going to bring outside the parentheses. 2. Now, 2 times what is 4? 2 times 2. I'm going to bring down my negative sign. 2 times what is 10? It's 5. Bring down the z, and I'm left with 2 times the quantity 2 minus 5z. Again, one way to check it is 2 times 2 is 4. And 2 times 5z is 10z. So I'm back at the beginning. I know I got it. All right, in the next problem, I have 8f plus 6. Actually, I'm going to do number 16 because the rest of them seem like there's an addition, so I want to do another subtraction problem. In number 16, I have 12 minus 8x. So let me look at 12 minus 8x. I'm going to break down 12. 12 is going to be 4 times 3, 2 times 2 times 3 when I make my factor tree. 8x is going to be 8 times x, which is going to be 4 times 2 times x. Remember, keep bringing down the stuff you didn't touch. Final product of primes, 2 times 2 times 2 times x. Now I have to look for all my partners. I see that I have a 2 in the 8x and a 2 in the 12. I also have another 2 in the 8x and another 2 in the 12, and those are the only partners I have. So my GCF is going to be 2 times 2, which is 4. So the number I'm going to bring outside is 4. 4 goes into 12 3 times, minus 4 goes into 8x 2x times. Okay? Let me do one more subtraction problem with you guys. Let me do number 20. Okay? So I'm going to go down to number 20. So I'm going to have 32m minus 40. So the first thing I'm going to do is do 32m. I know that's 32 times m. Then, you could break this up whichever way you feel most comfortable. I'm going to break it up in 8 times 4. Then I'm going to break this up into 4 times 2 times 2 times 2 times m. Not done yet because 4 is not prime. 2 times 2 times 2 times 2 times 2 times m. So that's a big factor tree. Now I have 40. I know 40 is going to be 10 times 4. 5 times 2 times 2 times 2. Okay, so there is my complete list of products of primes. Now I need to look at the numbers they have in common. I see they both have a 2, they both have another 2, followed by another 2. Those are the numbers they have in common. So my GCF is going to equal 2 times 2 times 2. My GCF will be 8. I'm going to bring 8 out into the front of my parentheses. So what times 8 is 32? I know that's 4 with an m attached to it, minus, I know 8 times 5 is 40. So my answer will be 8 times the quantity, 4m minus 5. So I'd like you to try the problems 12, 14, 17, 18, 19, and let's do 22, 24, and 26. Okay? I'd like you to try those out on my own in your notebook. Right now, if you could pause the video, I will write the answers on the board, and then you can see if you got them right. So go ahead and pause the video now. Okay, here are the answers to the on my own problems on page 243. So for number 12, it's 2 times the quantity 2x plus 3. For number 14, it's 5 times the quantity x minus 2. 17 is 2 times the quantity 4f plus 3. 18 is 4 times the quantity 3t minus 2. 19 is 5 times the quantity 3 plus q. 22 is equivalent. 24 is not equivalent, and 26 is not equivalent. Feel free, if you have any questions, to email or ask questions during class. Do the best you can, and there will be some classwork that follows. Have a great day. Bye.